No other time in the building history do we have a better understanding of what we built and what we can build. Home Building Crossroad can be a way for people to understand that our goal is to put a house in a position for success.
Pete Yost here for the Unbuild It Show, broadcasting live from Brattleboro, Vermont, in my basement, which is the Wingnut Test Facility, hence the hat. This is Steve Basic's favorite hat, by the way. And along with the hat, of course, you have to have the complete outfit, which is a shirt with a psychrometric chart. My wife says that when I dress up, I really kill. In any event, what is wingnut testing? Well, many times when we're working on projects with materials, particularly new materials, they are conforming to standardized laboratory testing. You know, constant humidity, steady temperature, clean and dry materials, conditions that have nothing to do with job sites and outdoor conditions. So the wingnut testing, hence the hat, is benchtop testing or conditions that reflect what's going on in the field. If you go to greenbuildingadvisor.com, I've done a whole bunch of wingnut testing, which means real-world field or benchtop testing materials under conditions that actually occur on job sites for things like negative side waterproofing in basements, pressure-sensitive adhesive tape testing, and soffit to ridge vent testing as well. All kinds of stuff. But today, we're going to talk about a special type of wingnut testing. I was working on a project where there was a leak in a ceiling, and we're having a hard time tracking it down. And it turns out that on a standing seam metal roof, there was the standing seam metal roof right against the roofing underlayment, which was on the sheathing. And it turns out for all the testing for weather-resistant barrier for walls and for roofing underlayments, the tests don't involve water held in tension in constant contact between two surfaces. Now, if you're doing rain screen or vented assemblies, that's fine because the water is free to pass because there's space between the cladding and the weather-resistant barrier or the roofing underlayment. And that type of water management is sort of what the tests that are standardized are conditions that they test. But we don't really have a standardized laboratory test for what happens when there is no space and water is held in tension. So because I wanted to test the roofing underlayment for this particular project I was working on, I devised my own wingnut test. And so here's what it looks like. I took a piece of the sheathing, OSB. This is my other side of the laboratory here. This is a laboratory scale. So very carefully weighed this. You can see this is sample number 1. It's 0.16363 pounds. But another way I can tell what the moisture content too is to take a moisture meter, and this is a pen type moisture meter. By the way, this is the brand new Downhorse BDX 30. We're going to do a wingnut presentation on this later, but a brand new off the press, really high performance tool that's linked to the internet. More on that later. But in any event, I can put this in and get a percent moisture content to show what the initial moisture content is of the OSB. Okay? And then if I set this up in my assembly and I have the piece of flashing represent the the metal cladding on the roof, and then the WRB here, I can take distilled water and insert it by letting it bead right on the top. I'll move a little closer here. Let the water bead right on the top and run down between the roofing underlayment and the metal representing the standing seam roof. Now what's neat about this is there's a little bit of space here, but here this would represent sort of a fastener and really tight tension or pressure between the roofing underlayment and the metal cladding. But over here it's, you know, it's a little bit looser. And so I very slowly drip water down, measuring how much water I'm putting there. And then what I can do is tell how much water runs out the bottom. As I'm doing this test, I put it in a tub, and I can keep track of how much water is flowing past and running out the bottom, and then how much is being held in tension. But then what I can do over time is take the assembly apart simply by removing the clamp, and then I can roll the underlayment back and see how much water is getting to the OSB, if any. That's sort of a qualitative test. But then if I redo my moisture test with the moisture meter, right, I can see if the percent moisture content rose. But then the real fail-safe way is to take the same sample of OSB that I measured, initially, and see how much weight gain there is. And that's an even more accurate way of testing how much water has actually been absorbed getting past the roofing underlayment. Now it turns out, I know you're going to know this, this is GAF deck armor, and I've done this test already for this particular material, and I got 0% of the water held in tension moving to the OSB beneath. But there's a whole bunch of other materials that I can test. Different types of weather-resistant barriers. I can test the coatings on like the zip assembly or the GAF force field, which is this material here. I can test building paper to see how water does or does not move through weather-resistant barriers or roofing underlayments when the water is held in tension, because the codes simply don't cover that. So that's the Wingnut test on this Unbuild It podcast and YouTube channel show. And I look forward to seeing you next time when I'm going to report on some tests of specific materials, and we'll see how she goes. Thanks from Pete Yost in Brattleboro for the Unbuild It Show.